Alright everybody, welcome back. This should be the final episode to the series. With any luck, we should have some positive testing. We're going to test all the different connectivity scenarios, site 1 to data center, site 2 to data center, and then site 1 to site 2. That should also verify if our ADVPN, the automatic discovery VPN, is working properly. And then we'll introduce some packet loss and stuff and see what the SD-WAN environment does based on everything that we had configured thus far. So let's jump in. So I'm on PCA, PCB, and server 1. So let's just see. PCA looks like he has 10.1.1.10, PCB has 10.2.2.10, and server 1 has 10.0.0.10. So that should jive with our key. So 10.1.1, 10.2.2, and 10.0.0. So that's good. Alright, so let's do some basic tests. So PCA, can he ping his default gateway? Good. PCB, 10.2.2.1. Whoops. Server ping 10.0.0.1. And then go back to PCB. 10.2.2.1. Okay, so they can all reach their default gateway. That's great. So let's just do from PCA, can he ping the data center? 10.0.0.10. Okay, so that looks good. Ping PCB to data center. Ping 10.0.0.10. Okay, that's good. And then let's do internet real quick. Ping 8888. Site A is good. Site B is good. And the data center is good. Okay, last test is site to site. PCA trying to ping 10.2.2.10. Okay, so we have site to site issue right now. Okay, let's go to, so that was PCA trying to ping PCB. So site 1 tried to reach site 2, had no luck. Now he should be routing through lab firewall 04 to get there, and then automatic discovery VPN should work after that. So let's check the logs on firewall 4. Is he getting it? Source, it was site A, right? Site A. Which one did I do? So source should be 10.1.1.10 going to 10.2.2.10. (10.1.1.10) going to 10.2.2.10. Received nothing, sent nothing, and it was denied. It was denied. Source interface, internet tunnel, destination interface, internet tunnel. I don't think we did branch to branch. Right. So in our firewalls on the head end, we took care of SD-WAN out, which is anything from our loopback or LAN going to the branches. We have a rule for that. SD-WAN in, which is the reverse of that one, we have allowed. However, we can see on the logs that it was trying to go to internet tunnel, so branch to branch. We don't have a rule that specifies that. So let's create that rule. So branch to branch. So essentially anything coming in on the tunnels and going out the tunnels. Source, all, destination, all, service, all. No NAT, we'll log this, okay. And let's stick that there. Okay, let's try that ping one more time. Okay, so that makes sense. That's what we missed. So if we go back to site B and we try to ping 10.1.1.10, okay, good. So now spoke to spoke is working. Now here's the end all tell all. Is our automatic discovery VPN working? So if we go back to the IPsec monitor, so if we look at the IPsec monitor for our 2 branch sites, awesome, check this out. So see, the way the Fortinet FortiGate does it is these are the top and bottom are the 2 static tunnels that we built together in the first couple videos, right? So they've been there since we built those, right? But then you see this next tunnel, which has this _0, which you can see has, now I'm on the site A, firewall 1. You can see the peer ID is firewall 2. So it spun up a dynamic tunnel straight to firewall 2 over the internet. Okay, let's see. So we know our ADVPN is working as expected. Now let's do some failover testing between, branch site, data center, and then we can do branch site, internet, just to kind of compare everything. We'll summarize, hopefully, and wrap up with that. So what we'll do is we'll hop on PCA. So let me see if I can split the screen here a bit. All right, so PCA is 10.1.1.10. Server 1 in the data center should be 10.0.0.10. We should have reachability from site 1 to the data center, which we do. Let's do a trace route, and we should see it ride the MPLS, which we do, right? 164.1.1. We know that that's our MPLS transit, and that is based on our cost under the SD-WAN zone, right? So we know that we have a cost of 10, so we're favoring MPLS. Therefore, our rule should say for the SD-WAN out, we want to take the MPLS tunnel. So what we'll do is we will fire up a ping to 10.0.0.10. We'll do 50 of them. So we know that's riding the MPLS circuit, right? So let's start that ping. We'll come over to that link and we will suspend it. Okay, so we lost a ping. We can see the MPLS tunnel is down. And we can see that our rule switched the checkmark to the internet tunnel. So that's pretty good. That is pretty good, right? So I'd say 1 ping is perfectly acceptable. Even on a voice or video call, that's tolerable. That's really good. So let's let those pings finish. We'll do a trace route just to verify that, trust but verify. Okay, so let's do a trace. Awesome. So we can see that it's now riding 0.1, right? So a minute ago it was 1.1. Now it's 0.1, which we know is internet. And all the evidence points to the convergence was really quick. We lost a ping. Let's fail it back and see how it does the other way around. So let's restart that ping. Let's come back to our topology. Let's resume that link. Okay, so now we're kind of in that pattern where we have to wait for the packet loss to come down under what we dictated was acceptable. So we're just kind of waiting at this point. Hopefully I did enough pings. We'll see here. Maybe not. It's gonna be close. I might have to catch this just at the right time. Yeah, I'll hit the up arrow and start them again here. We should be good. Okay. So it's 12%. So a couple seconds here. It should move. It should attempt to move the traffic back, and we'll see if we take a hit or not. Okay, so it moved it back to the MPLS tunnel, which is awesome. We're back to a green state. Far as I can tell, the PC did not have any issue with connectivity there. So that's actually really, really good. Yeah, that's perfectly acceptable in my opinion. So we'll do a trace route once these pings expire just to make sure it bounced back. So we see it riding 1.1, which obviously is MPLS. So that was a successful test in my opinion. That was pretty good, pretty good. Okay, so let's do internet. So from PCA, I should be able to ping 8888, which I can. Let's do a trace route. We might see some asterisks here, which is kind of normal. We have reachability. We know we went to the default gateway of the firewall. We did not see any 100.64 hop, which means it should be going DIA, which we know is based on our SD-WAN rule. We can see, and our SLA is up, so we should be doing DIA. So let's go ahead and fire up 50 of those pings to 8888. We'll hop over to the topology and we will suspend the link to the internet. So far, same story. We lost one ping. We can see we lost the SLA to the internet as well as the internet tunnel. The MPLS tunnel is still intact. The SD-WAN rule says in order to go DIA out, you're now going to use the MPLS tunnel. So that's awesome. So that looks like it's working as advertised. So we have about 15 pings to go. We'll do a trace route, and what I would hope to see is a 100.64 hop, which is indicative of the backhaul. And we can check logs too, by the way. So let's do a trace. See that? So there's the difference. So a minute ago, it was just 10.1.1.1, but now we can see we're riding the MPLS, which is 1.1 based on the topology, right, to get to the internet. Now, if we go to Lab Firewall 4 and we go to logs, forward traffic, let's do source IP equals 10.1.1.10. So we can see that literally a minute ago, if we drill into this, we can see that source was 10.1.1.10. It got natted, right, because it's source nat based on this branch backhaul firewall rule. It rode the MPLS tunnel, which is exactly what we expected. It went out port 2 of firewall 4, and you can see it matched the policy ID 3 branch backhaul. So that did exactly what we expected to do. Let's fail it back and let's see what happens coming back. So start that ping again. We're going to resume this link. We're going to have to wait out the countdown timer here. And by the way, this is, so when you drill into this, you can change the thresholds, right? Like you can adjust some of this stuff depending on how aggressive or not aggressive you want to be. And I'll touch on that in a minute, actually. Let's see how this does. So I'm going to have to hit the up arrow again. I'll catch it in time here. Okay. So it should be flipping in a second or two. So we're back to port 2 for DIA out. Performance SLAs are all intact. We didn't miss a beat. I mean, this is actually pretty good, right? So this is, again, product of our hard work, right? We have everything kind of nailed down as far as failover situations, convergent goes, all that kind of stuff. It seems pretty good as far as time it takes to converge too. I'm pretty impressed with one ping. So that's downing interfaces and rerouting based on down events. Let's introduce packet loss, the concept of packet loss, and see what happens. Now, in my opinion, this is where things get interesting. So in some of my previous testing, I got some pretty undesirable results with what we're about to check out now. And hopefully we'll see that live here, and I'll try to explain what I think is happening, right? So we'll concentrate on the data center test again. So we'll ping 10.0.0.10 50 times. But this time, instead of downing the link, I'm going to introduce packet loss via even G. So we'll see what this does. So first of all, let's just trace. So we're riding 1.1 at the moment. Okay, 1.1 is MPLS. That's proper. That means our cost is taking effect, and we're favoring MPLS. So nope. Oh, I hit the wrong button. Sorry about that. You know what? That's fine. We'll test it with the internet. It's fine. Let's introduce some packet loss here. So let's add 10% packet loss to that link. We get an amber light right next to the internet switch indicating that it's packet loss. If we come back to the firewall, performance SLAs, we can see that we've hit 5% packet loss on internet port 2. Our SD-WAN rule has already switched to MPLS tunnel for the internet, and it does not appear that we had any detriment, which is good. That's good. So if we trace route to 8888, we can see we're riding the backhaul, which is proper. Okay, so that's good. We can see that loss is still happening, so it's routing around the packet loss event, which is fantastic. That's what we want. So we'll revert it back and we'll see what happens here. So let's restart the ping. Let's do 75 because it seems like I never have enough time. Okay, so let's restart that ping. Let's get rid of the packet loss. All right, and then we'll watch our SLA come back in service. So it's already starting to drop. Slowly but surely. Okay, so we're back in the green. Still a little bit of packet loss on the internet tunnel. It's probably going to take some time to clear. But the point is we're in the green as far as our SLAs go. We didn't skip a beat. Pings look good. We can see DIA switch back to port 2, which is what we want to see. So when these pings finish, we'll do a trace route just to make sure. But I mean, so far testing's actually, this is the best I've seen it, to be fair. I think we have one more test to do, which is the data center connectivity with packet loss. We'll see how it handles it. I haven't seen results this good so far. I'm actually kind of surprised. I'm pleasantly surprised, but. So if we trace route, we can see we don't have the 164 hop, which is indicative of DIA. And what we should see on the logs of this box, So if we do source IP is 10.1.1.10, so we can see it didn't come in yet actually. Let's refresh. There we go. So these are the fresh logs. You can see they're all DIA out. So if we hone in on one of them, we can see that source 10.1.1.10, it got added to our branch site, which we know is DIA. It went out. It came in port 3, went out port 2, destined for 8888, and it matched policy ID 3, which is DIA. So that's perfect. All right, awesome. So let's go back and do data center test. Everything's back in the clear. We're green. Everything's perfect. We are favoring port 2 for DIA and MPLS to the data center, which is what we expect. Let's ping. Let's trace just to trust but verify 10.0.0.10. We can see we're routing MPLS. So let's ping 10.0.0.10 50 times, and we'll introduce some packet loss to that link. Of course, Eve wanted to log me out. All right, let's introduce packet loss. Let's go 10%. Okay, so we can see some timeouts happening. Another one. Another one. So this is where we start to see some interesting results here. Okay, so now the SLA is picking up on the loss, right? So these timeouts here were most likely the packet loss that we were experiencing, but the SLA didn't pick up on it yet. So we were essentially, I'll start the pings again. We were essentially just kind of dealing with the packet loss, okay? But now at this point, it looks like it moved the traffic to the internet tunnel. And that's going to be based on the SLA having packet loss, right? So, but the interesting thing is we're still seeing timeouts, right? Which, if it moved us to the internet side, why are we still seeing timeouts? And this is where my testing got kind of interesting, right? So let's let these pings expire, and I'll see if I can explain. We'll see if we can get some verification here on what we're seeing. So it doesn't seem too bad. It seems like it cleared up. Let me do 50 more just to see if it kind of stays stable. Nope, see that? Okay, so yeah, so we're having packet loss. The rule says that it's chucking it out the internet side, right? But let's hop over to let's check our routing table. So on branch A or site 1, whatever you want to call it, if we do get router info BGP network, and let me make this a little bigger. So for the data center subnet 10.0.0./24, our best route is saying 164.1.1, which 164.1.1, it keeps logging me out. That's the MPLS, okay? So what's happening here, right? So it's saying that the best route is MPLS. However, the SD-WAN rule says internet tunnel is supposed to be used. And this is what kind of happens with the Fortinet SD-WAN solution. So if your underlay routing is, let's say, different than what the SD-WAN rules are trying to dictate, it gives some undesirable results. So your tables, you have to try to match your table in order for it to kind of work the way you expect it to. The other weird situation that I was getting into was on the data center side. If we go to this firewall, and let's do a get router info BGP network. So it's saying that the best route to get to site 1 is 0 dot. Okay, so 0 dot is the internet, but when you look at that from firewall's perspective in site A, it's saying 1 dot, right? So, and that's because of the local preference, right? So essentially what's happening is it's going out one link, but it's coming back the other, which is why we're still seeing packet loss, because we introduced packet loss on one of the links. So it's going out the internet side, gets up to the firewall, and then it's coming back over the MPLS side. So that's some of the undesirable results I'm kind of talking about. We saw really good testing when we downed circuits. We saw that we only lost a ping. In some cases, we didn't even lose a ping, which is awesome. That's what you want, right? That's like the perfect situation. But when we introduce the packet loss, we're kind of seeing some undesirable results. So something to consider if you put this in like a production environment or whatever is you're going to want to put some time and effort and focus on your underlay routing scheme and how your traffic's flowing, because you might see some of this. Now, if the packet loss was bad enough to break the BGP peering, I would expect it to be better, right? So what's happening now is we're kind of dealing with the packet loss because the BGP is still up, so it's still using the underlying routing table. But if the BGP peer goes down, then it should remove those routes from the table and route around the packet loss, right? So that's, I think, the better situation. That's what you would want to see. But you're going to have to play the game of, let me show you what I mean. You're going to have to kind of play a little bit of a game as far as your thresholds go. So when you come over to your performance SLAs and you come in here, so right now we're saying tolerate 3% packet loss. So remember, guys, like packet loss isn't good ever, right? Like you never want packet loss. So what we're saying here is if we're operating at 3% packet loss or less, just deal with it, right? So we can have 3% packet loss, which is going to give us connectivity issues, but it's not going to try to move the traffic to another link unless it's more than 3%. So in my opinion, if you're too aggressive with this number, if you say like 1% packet loss, it's going to be moving traffic around left and right every time there's 1% packet loss spike, right? Which could be a bit too aggressive, and you might start to see inadvertent ping loss and connectivity issues because you're moving traffic so quickly. If you increase the packet loss, you're not going to move traffic as quickly, but on the flip side of that coin is you have to deal with the packet loss. So you're going to have to play that game and try to figure out what that magic number looks like, in your case. But maybe you're not doing like collaboration stuff. Maybe you're not doing voice over IP video, stuff like that, in which case this is kind of acceptable. But if you're doing voice or collaboration stuff over your circuits, then this might be a headache for certain environments. So let's go ahead and just clear that link now. So let's bring it back to a clean slate. All right, good. I think, so in my opinion, the testing did not go terribly bad. I think the testing went quite well. We've proven that the automatic discovery works spoke to spoke. We've failed over every which way for internet to backhaul to just straight branch connectivity to the data center. The best results are when the circuit goes down completely. You get some undesirable effects when you just introduce some packet loss, stuff like that. Now, I will say this too. The Fortinet SD-WAN, they offer what's called a preferable route map that you can attach to a BGP neighbor under SD-WAN. And what that means is it'll bind itself to the performance SLA. So you can say in our case, this lab firewall 1 has a BGP peering up to the data center firewall. You can attach a preferred route map to that peering that says, hey, as long as the SLA is green, advertise what's in this route map. So you can have a prefix list or something that advertises, or communities, whatever it is you want to advertise, but it'll advertise based on the SLA being up. If the SLA goes down, the preferred route map goes away and it falls back to a normal route map, which could have a different kind of condition or a different kind of advertisement or whatever it is inside of it. So maybe that's a solution for this packet loss situation. I don't know. And I'm not going to, I wanted to keep this video or this series to just the underlying SD-WAN and its functionality. But there are some enhanced features, maybe timers, all that kind of stuff. We didn't really tune that stuff. So maybe that's a solution too. But at any rate, I wanna wrap up by saying a thank you. I appreciate your time. Hopefully, I hope you watched all the videos. I hope you watched it in progression. It will demonstrate how to get from point A to point B. And I think that the failover went quite well. As far as the overall Fortinet SD-WAN kind of solution goes, I think it's compelling. I think that, for having a firewall that has all of it on box is again, it's very compelling. So you get the security aspect of it because it's a firewall. You get the routing and arguably the switching out of it as well. And if you bolt on access points or switches, these firewalls can become the controllers for all that stuff too. So you can have an all-in-one solution with just a firewall, and you can have your APs registered to it as a wireless controller. If you add switches, they become FortiLink enabled switches, and then you can manage the whole solution with like FortiManager and stuff like that. So it's a very compelling product. There's a suite of products that you can bolt on and really have an all-in-one solution and what they call the security fabric. So I think it's a good solution. It depends on how strong you are with routing, switching, and all that other stuff as well. So make all those considerations, and I encourage you to get your hands dirty with it as well and see how you like it. So again, thank you. I'll stop babbling, and I hope you guys got something out of it. And I look forward to doing another series soon, and I hope you guys tune in. So thank you very much.